Hey, my name is Darshan Patel, and this is my lab for Physics 2 Projectile Motion. So in this lab, our objective was to observe and video record the motion of an object that is thrown and moves like a projectile. For example, you could throw a loosely wadded paper ball and act like you're shooting into a trash can, but we chose to use a ping pong ball that our lab TA gave us. And the motion of the object should be two-dimensional, and the video should capture the motion across the screen. So the object shouldn't be coming towards you or moving away from the point of view of the camera. We also should not move the camera while capturing the motion. We made sure that it was a steady, constant frame. And we also made sure that we knew the mass of the object, which was standardized because it's a ping pong ball that had factory regulations. And we also made sure to calculate the height and with respect to the floor table and other surfaces from which it was thrown. So using Tracker. So we use Tracker to analyze the video and extract the object's motion data. On Tracker, we set the scale of the scene with the calibration stick, and we also made sure to have a meter stick in the video. When putting down the coordinate axis, we put the x-axis on the floor and the origin directly below the initial position of the thrown object. So this is a photo of us making the video and also like a tracker snapshot. So in this photo, you could see that the path of the object is shown with like the diamonds on the screen, and you can also see some of the values that we got, like the distance that traveled per second and everything, and the meter stick in the background too, as used for calibration. And now using GlowScript, we constructed a computational model based on physics principles like Newton's second law, or equivalently the momentum principle, which includes only the effect of gravity on the object. We used the starter code that was given, and we added a few lines to it to make sure they gave us the data that we wanted. And then also, after constructing the first model that only had gravity, we made a second model that includes the effect of both gravity and air resistance, or drag. The air resistance should be modeled as a force that always points in the opposite direction of the motion of the object and has a magnitude that is proportional to the square of the object's speed. The drag force formula is therefore the vector of F drag minus B v squared and times v hat, where b is proportionality constant that we will determine using our experimental data. We use the fact that the speed is the magnitude of velocity, and it needs to be squared to help us in our GlowScript data. The direction of motion is given by the unit vector of the velocity vector. And so this is some of the code that we wrote. So most of it was just the generic starter code data that we got, but we had to alter some things like the ball.m, which is the mass of the ball, which is in kilograms, and then the position and the velocity that we got using our data. And then we also had to put in the gravity vector, and then we also had to put in the drag coefficient, which was b. We had to tamper around with that coefficient to try to get it as accurate as the tracker data that we got, so that we could kind of estimate what the drag was. And then so this is the GlowScript data. The one on the left shows with drag, and the one on the right shows without drag, and you can see how much farther it goes without drag in like an ideal scenario. And so these are the plot comparisons that I did on Excel. You can see that the blue is the tracker data, and then the orange is GlowScript with drag, and then the GlowScript without drag is gray. And this is shown as distance versus height, and you can see that the one without drag goes much further than the ones with drag. And you can see that tracker and GlowScript are pretty similar to each other, the one with drag. And for our discussion, none of the models show terminal velocity, because for the GlowScript with gravity, there's no way for it to reach terminal velocity due to there not being drag. And for the GlowScript with drag, the object does not fall long enough to reach terminal velocity. For there to be terminal velocity, the object needed to have been dropped much higher, which we could have altered in the experiment to reach. Also, if the object was thrown straight up, and we assumed that the same amount of force was used, then the object would reach a higher height because no force would be used on the x-plane. Furthermore, this would increase the amount of time needed to hit the ground. That's it for this lab. Thank you.